Ever pondered about how our planet, Earth, evolved from a barren, rocky, and hot object with a thin atmosphere of hydrogen and helium into the beautiful, water-abundant, life-sustaining entity that it is today? There exist a series of events and processes throughout the course of over 4,600,000,000 years that steered this extraordinary transformation. Starting with the Earth's initial volatile state during its primordial stage, the increase in density led to the rise in internal temperature. This caused the material inside to separate based on their densities. The heavier materials, like iron, sank towards the center, while the lighter ones ascended towards the surface. Over time, the Earth cooled, solidified, and condensed into a smaller size, leading to the formation of the outer surface or the crust. The formation of the Moon, due to a giant impact, further heated up the Earth. It's through the process of differentiation that the Earth-forming material separated into different layers: the crust, mantle, outer core, and inner core. With each layer, the density of the material increases from the crust to the core. The evolution of the atmosphere and hydrosphere is equally intriguing. The present atmosphere, chiefly composed of nitrogen and oxygen, evolved through 3 stages. The first stage saw the loss of the primordial atmosphere due to solar winds. The second stage was influenced by the hot interior of the Earth. Finally, the composition of the atmosphere was altered by the living world through the process of photosynthesis. The early atmosphere, filled with hydrogen and helium, is believed to have been stripped off due to solar winds. As the Earth cooled, gases and water vapor were released from the interior solid Earth, marking the start of the evolution of the present atmosphere. This early atmosphere mainly contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little free oxygen. The process through which the gases were expelled from the interior is termed degassing. Continuous volcanic eruptions further contributed water vapor and gases to the atmosphere. As the Earth cooled further, the released water vapor began to condense. The carbon dioxide in the atmosphere dissolved in rainwater, which resulted in further cooling and more rainfall. This rainwater, collected in surface depressions, gave birth to oceans. From a hot, barren, rocky object with a thin atmosphere to a thriving planet with a layered structure, conducive atmosphere, and ample water, the Earth's evolution is a fascinating journey of over 4,600,000,000 years. A testament to the dynamic nature of our planet, this journey continues, shaping and reshaping the world as we know it. Have you ever wondered just how old the Earth's oceans are? Or when life first began to stir in their depths? It's a fascinating journey that takes us back billions of years to a time when our planet was just beginning to form. Picture this. Roughly 4,500 million years ago, our planet was born from the stardust of a collapsing nebula. In the chaotic aftermath, a molten mass of rock began to cool, and the first solid crust of the Earth was formed. But it was still a barren wasteland devoid of life and water. So where did our oceans come from? Well, about 500 million years after the Earth's formation, the planet began to outgas water vapor, which eventually condensed to form the oceans. This means the oceans are nearly as old as the Earth itself, with an estimated age of around 4,000 million years. But it was not until around 3,800 million years ago that life began to evolve. The Earth's early atmosphere wasn't exactly welcoming, but somehow, through a series of chemical reactions, complex organic molecules began to form and assemble themselves. This process transformed inanimate matter into a living substance, marking the birth of life on Earth. Yet life was confined to the oceans for a very long time. It was in these primordial waters that the process of photosynthesis first evolved, sometime between 2,500 to 3,000 million years ago. Through photosynthesis, tiny oceanic organisms began to produce oxygen, gradually saturating the oceans with this vital gas. By 2,000 million years ago, the oceans were brimming with oxygen, which began to flood into the atmosphere. This oxygen-rich environment allowed for the evolution of more complex life forms, setting the stage for the incredible diversity of life we see today. The evidence of this ancient life is found in fossils within rocks, a record of the organisms that once thrived on our planet. Microscopic structures closely related to modern blue algae have been found in formations over 3,000 million years old, providing us with a glimpse into life's humble beginnings.
In summary, the Earth formed around 4,500 million years ago, with the oceans appearing shortly after. Life began to evolve around 3,800 million years ago, initially confined to the oceans where photosynthesis began. The oxygen produced by these early life forms eventually saturated the oceans and flooded the atmosphere, paving the way for more complex life to evolve. So the next time you stand by the ocean, remember its ancient origins and the incredible journey of life it has nurtured over billions of years. It's a testament to the resilience and adaptability of life, and a reminder of our own place in this ongoing story.